we're asked to consider the given integral and make the substitution u equals x cubed minus 8. So if we let u equal x cubed minus 8, the next step is to find differential u, where differential u is equal to u prime times dx. U prime is equal to the derivative of x cubed minus 8, which is 3x squared, giving us differential u equals 3x squared times dx. Now looking at the integral, since we let u equal x cubed minus 8, this part of the integral is now u to the 5th, and notice how we're left with x squared dx. But we have 3x squared dx, which means the next step is to divide both sides by 3. So if we divide both sides by 3 and simplify, we now have 1/3 differential u is equal to x squared dx. And now let's write the given integral in terms of u. We now know x squared dx is equal to 1/3 du, and since u is equal to x cubed minus 8, we also have u to the 5th. So making the substitutions, we have 1/3 times the integral of u to the 5th differential u. And now let's take a look at our questions below. Part A, we're asked to write the 5th power of x to the 3rd minus 8 in terms of u, which we now know is u to the 5th. Next, what is x squared dx equal to? Well, we know x squared dx is equal to 1/3 du. The du is already here, and therefore we only enter 1/3. Part C, we're asked to rewrite the integral in terms of u and du, which we've already done. Find the antiderivative in terms of u, and then in terms of x. So let's go ahead and integrate with respect to u, which gives us 1/3 times u to the 6th divided by 6 plus c, which is equal to 1/18 u to the 6th plus c. So the plus c is already here, and therefore we enter 1/18 u to the 6th. And now to find the antiderivative in terms of x, we substitute x cubed minus 8 for u, which gives us 1/18 times the quantity x cubed minus 8 raised to the power of 6 plus c. And again, the plus c is already here. We only enter 1/18 times the quantity x cubed minus 8 raised to the power of 6. I hope you found this helpful.